this lesson, we're going to look at what we call maximum and minimum values. So we've already touched on this topic when we did curve sketching and finding local maximum and local minimum values to find critical and critical numbers. But here what we're going to talk about is what we call an absolute maximum. So if you have a function, f at x, then that function will have what we call an absolute maximum at c. So this would be your c value if f of c is bigger than f at x for all x in the domain of x in f. So that basically means the y value at c is bigger than all the other y values for the whole function, not just around. So there's no arrows going up in this case. They get higher than this point b. And then it has an absolute minimum if the opposite true. If f at c is smaller than or equal to f at x for all x in the domain of c. So the y value for this c value at this point a is smaller than all the other y values. So that's all we mean by absolute max and min. So it's just slightly different, or it's different than the concept of a local max and min. So we have a rule, and that states that if a function is continuous on a closed interval a to b, then there will always be a maximum and a minimum value, and they will occur at either the critical number. So if you remember, that's the same as with local maximum and local minimums. It could occur at a critical number, or it could occur at the endpoint. So the reason sort of we state this rule, or what it's important to kind of understand about this rule, is that a function, not all functions have maximum and minimums. Like for example, like if you took your like a parabola, well, it would have a minimum at the critical number or at the vertex, but it doesn't have a maximum. But if you close the interval, so set restrictions on the interval, so there's no more arrow here, and we just say it doesn't go past the point B and doesn't go past the point A, then there will be a highest number, right? Like in this case, it would be this y value, which happens at the endpoint, would be its largest value. So if you restrict the domain on a closed interval, then you guarantee yourself that you're going to have both a minimum and a maximum. And that could either occur at the critical numbers or at the endpoints, which this theorem or this rule will be used for us to figure out these maximum and minimum values. So let's take an example. So determine the maximum and minimum values of this function f at x on the interval. So notice it's a closed interval. So in order to figure out the maximum and minimum values, we have to first, basically we have to look at these two things: the critical numbers and the endpoints. So the endpoints are given, right? -4 and -1, but the critical numbers aren't. So the first thing you have to do is find the critical numbers. So all that means is take the derivative. So f prime at x equals 3x squared plus 12x plus 9. Set it equal to 0. And so we'll have to solve, so you factor 3. So the factors here are plus x plus 3 and x plus 1. So that means we have x plus 3 equals 0, or x plus 1 equals 0, which would mean x equals -1, or x equals -3. So those are critical numbers. So therefore, the critical numbers are -3 and -1. So -3 and -1 are potential points where you could have a maximum and minimum. And then from the rule, you could also have it at the endpoint. So the endpoints were -4 and -1. So there's sort of 4 points, -4, or 1, and -3, -1, where you could have maximum minimums. So we have to figure out which one or which two, like which one's the maximum, which one's the minimum. And that's the second step. And in order to do that, all you have to do is figure out what is the y value. So evaluate f at x at the critical numbers. And the endpoints. So we'll start with the one endpoint, so f at minus 4. So figure out what's f at minus 4. So it just means sub in minus 4 into the equation. So that would be minus 4 cubed plus 6 times minus 4 squared plus 9 times minus 4 plus 2. And then evaluate. So you could just work that out. That works out to minus 2. Then I'll go in order, so from smallest to biggest. So the next point I need to evaluate is at the critical number negative 3. So do the same thing. So minus 3 cubed plus 6 times minus 3 squared plus 9 times minus 3 plus 2, and kind of work that all out, and you get positive 2. Now I'll do the next critical number, which was negative 1. So minus 1 cubed plus 6 times minus 1 squared plus 9 times minus 1 plus 2. Work that all out, and you get minus 2 again. And then the last critical number was, or not the last critical number, the biggest endpoint was 1. So f at 1. So 1 cubed plus 6 times 1 squared plus 9 times 1 plus 2 equals 18. So we get these 4 y values. So the maximum is just the biggest one. So that would be 18. And the minimum is the smallest one. So these kind of, these two both are the minimum. And it's possible to have that minimum value occur twice. So therefore, the maximum value is 18, and